Okay, we're looking at the heating curve problems, water only. So as you remember, as we look at a problem, we want to make sure we highlight all the important numbers. So it tells us a 35-gram sample, and I'm going to underline that because that I know off the bat is my mass, of ice is heated from negative 25 degrees Celsius, which is telling me a temperature, until it's completely melted. How much energy is required? Now, the fact that it's getting melted isn't a number, but it's also something that is going to matter to me. And I'm solving for energy, so I'm looking for a Q. So the first thing with the heating curve problems that I've told you to do is draw a graph. Okay. And then we're going to mark any important temperatures we're given in the problem. So we were given a temperature here, so I'm going to mark that negative 25 degrees. And as we've been looking at these problems, there's usually some other temperature number given to you. And the fact that it says it's melted gives us a secondary temperature, which is the melting point of water, and we know it's water because it's talking about ice, is 0 degrees. So I'm going to put that right here. Okay. The next step is for you to look to see if the melting point or boiling point can fit in here. So the melting point is already listed, and the boiling point is 100 degrees, which doesn't fall in between these two numbers. So I'm done with marking my graph. Now I need to actually make my graph. So I told you that if you have the melting point or the boiling point in the problem, that you're going to draw a line. Okay. Now to connect this temperature to this line, we have to see if this is a heating or cooling curve. So it says it's being heated, so that means my graph is going to go upward. So I'm going to connect this line going up. And then the last thing I need to do with my graph is label what I've drawn. So I know that this is it's getting melted, so that this in fact has to be a solid, and we label our solids with A. Okay, and the melting process is B. So this is a two-part problem. So we're going to go and we're going to start with A. Since A is a solid, it's Q equals mass times the specific heat of a solid times the change in temperature for a solid. The mass we were given in the problem, which is 35 grams. The specific heat of the solid, you can look at the top of your worksheet, and that's 2.06 joules per gram degrees Celsius. And then change in temperature, remember, is final minus initial. Okay, so my final temperature is 0. My initial is negative 25. So 0 minus negative 25 is a change in 25 degrees Celsius. Okay, I write the units because you can see grams gets canceled, Celsius gets canceled, so you'll be just left with joules. And our answer here is 1,802.5 joules. Now, if you remember, we want all our answers to be in kilojoules. So I'm going to move this over. And that's going to turn that into 1.8025 kilojoules. Okay. We're done with that. Now we're moving on to part B. So B is the process of melting, which means we have to look at the heat of fusion. The equation that involves is Q equals HF times N. So our heat or fusion, that also you can look at the top of your chart. So Hn is 6.02 kilojoules per mole, and you're multiplying that by your number of moles. Now if you've forgotten how to do that, we have to convert our grams. I'm going to do this over on this side. So 35 grams over 1 times grams over 1 mole. Okay. We're looking at water. So the mass of water is 18. So in doing that, you'll find that you get 1.94 moles. And that's the number that we're going to go and use over here. So 1.94 moles. We multiply that and we'll get 11.68 kilojoules. Okay. So we're going to take our 2 kilojoule amounts. We're going to add them together to get our Q total. It's our total amount of energy, and that is 1.80 kilojoules plus 11.68 kilojoules. When I'm adding, I typically want to make sure that my numbers are rounded to the same point. So if I add that together, I'm going to get 13.48 kilojoules. And here's my answer. Now, if you rounded to a different point, your number might be slightly different than mine.